Hi, everybody. How's the conference going? Going good? Yay! I'm so excited to see so many people are interested in strong authentication. I know it's a topic that's not always the most exciting, but it's important, I swear, and awesome. And that's what we're going to be talking about now, which is why security keys are awesome and how to use them to protect yourself, your customers, and all that important data that we got somewhere. But before I get into that, let me tell you a little bit about myself. Hi, I'm Jen. I'm a security advocate at Google on Cloud Platform. And in that role, I spend a lot of my time researching security stuff relevant to cloud and then coming to events like this to tell you all some stories that'll hopefully help you use the cloud safer. My background before that is mostly software engineering, mobile and app dev for quite a few years. And now I do this kind of stuff. I always love hearing from people, so if I can ever help out with anything related to Cloud Platform, feel free to drop me a line. The easiest way to reach me is on Twitter, where I'm miming codes. Sorry? Oh, I got to stay within the pink lines. Thank you for the feed. I will restrain my walking to within the pink lines, or the live stream people will be sad. Hi, live stream people. Enough about me, though. Let me ask all of you some questions about yourself. So how many of you are security engineers or identifies, mostly security? Okay, a few of you. So I apologize ahead of time for some of the oversimplifications. It's hard to cram anything involving cryptography down into 30 minutes. How many of you currently use a universal two-factor authentication security key? Oh, 5, 6 people. Cool. And how many of you have had to clean up after somebody got phished? Were any of those situations yourself that got phished? Yeah, it happened to me once. It catches you sometimes. It's a bummer. OK, thanks for that. So here's what we're going to be talking about. Here's our agenda. First is passwords are bad, why they're bad, and why they're still bad. Then FIDO Alliance and its approach to giving us a solution that is better than passwords or authenticating users, how that solution, universal two-factor authentication, works, and how to use it yourself, and for your organization. So first, let's talk about the problem with contemporary authentication. We see forms like this all the time. We log in, we authenticate, and then sometimes that gives us access to a vast amount of privileges within an organization. Sometimes it's just as little as a username and a password. And over the years, we've tried to improve upon the shortcomings of passwords. We've tried to educate people. We've used password rules and complex secure, like complexity requirements. And despite all those efforts, we haven't really made any progress. It's probably time to give up on trying to solve the user problem because the most common passwords are still the same as they've been for a very long time. And even if people select strong passwords, there are new threats that are becoming apparent. Huge archives of passwords are getting leaked out, stolen, and reverse engineered. And because of that, a lot of breaches involve those lost credentials. And even if you have strong credentials and you don't reuse your password anywhere, you could still get phished. And these are situations that are getting more and more targeted. And it's not just assuming that education and being tech savvy will prevent you from getting phished. From my experience doing kind of red teamy stuff, that's not true. If you target something well enough and you hit someone when they're weak, no matter how elite they are, you can probably catch them off guard eventually. So just kind of set some context. Let's describe kind of a normal login flow and where those problems come up. We have a user, and they want to access some stuff on a service. They're going to enter a username. They're going to enter a password. And it's great. They're going to get access to all of the privileges they have on that service. That service is going to assume that that person at the other end is the right person and can do everything that they are authorized to do. But in a lot of situations like man-in-the-middle attacks or phishing as a version of man-in-the-middle, what happens is somebody convinces you, probably wearing a hoodie, hiding in a cafe somewhere, to enter your login and password into a fake lookalike site, maybe using a very similar-looking URL structure or something like that. And then they go and masquerade as you on that service, cause all sorts of problems. And they may even do this in a way where you don't even notice you've been phished until you start getting like weird events. You see weird things in logs or something like that. And that's a bummer. And we've had attempts to try and make passwords better. We have like TTOP and HTOP, like one-time passwords, where you have like an SMS that gets delivered to you with a code that you type in to verify that you not only know the login and password, but you also have control of that phone, or at least are the one receiving that SMS. You might have a program installed on a mobile device or a physical hardware device that has a synchronized clock with server-side that will give you a code to type in. And these help. They help with those cases of those large password breaches where people reverse engineer giant libraries of passwords. But they don't actually help with phishing very much, which is one reason that phishing is getting more targeted and more popular. Because a lot of our existing measures can still be defeated by that. They can phish your OTP, and then they go in there and then they disable their OTP or they add a new one or something like that. And before you know it, bad things have happened again because of somebody with a hoodie. It's always the hoodie. And this is a problem we've known about for a long time. So a bunch of big companies got together and formed the FIDO Alliance, which is an attempt to try and make this situation better. Because we can do better than passwords, I swear. They describe themselves as the world's largest ecosystem for standards-based interoperable authentication, which is quite a mouthful. And as you would expect for an organization that describes themselves that way, they, of course, communicate with the world through internet standards, long documents that I love to read at night to help me go to sleep, but a lot of other people do not enjoy as much. And there's actually some relevant news that just happened within the last several weeks. On March 20th, 2018, their most recent draft standard, a lot of the stuff that was in their FIDO 2.0 standard got accepted and is now a W3C candidate recommendation called WebAuthn. And it is cool, and it's very similar to the FIDO U2F stuff, except it kind of takes a step back. It covers it in a much broader perspective. It has opinions about different parts of user authentication. It is a much more complicated spec. I'm still digesting the current version of it. So, and it's also not going to be, it's not supported in a lot of places yet. So we're not going to talk about it too much, but it is definitely worth checking out if you're interested in this topic. We're going to talk about the specification that came just before it, which is conveniently, it's compatible with the WebAuthn stuff. So if you implement U2F stuff or you get U2F keys, you'll be able to keep using that as WebAuthn supersedes it in the future. So the FIDO U2F spec is a collection of specifications that's not part of W3C. It's from FIDO alone. And it defines a solution to that authentication problem. The TLDR of that is their solution is public key cryptography, which is great. I mean, this has been part of the solution for a long time. We could have always installed a certificate on our devices and used that to authenticate. But they're very, very hard to use, and they can still get stolen, like if your laptop gets, hijacked. So their solution is to take those same public key cryptography concepts and move them onto a little hardware device, like the one I have right here, which I hand drew a little picture of, except I made it darker colored. So why would we have kind of a separate hardware device that you have to carry around? Because no one likes carrying around dongles. But it's kind of worth it. The benefits outweigh the inconvenience of having to carry something around. First off, you get hardware isolation. So even if your laptop or your mobile phone gets rooted, it's going to be another whole step. They have to find another vulnerability in the hardware dongle to access all those nice juicy keys. So you get a little bit of benefit of a security there. The other benefit, which is around convenience, is it's kind of worth carrying it around because not only can I use it with my laptop, but this one also supports NFC and Bluetooth, so I can use it with mobile devices and multiple laptops, and I don't have to kind of keep installing certificates on a bunch of devices. And as a result of having a physical button, it's easy to use. There's a single button on it you press. It's actually pretty convenient once you get used to it. They also defined, the U2F spec also, in addition to defining the structure of those hardware dongles and how they work, it also defines kind of a transport method that you can use to communicate those cryptographic events between your device and your user. And those for like desktops, it's going to be USB. Mobile devices are a little bit harder because it's not as common to plug USB devices into your phone. So for those, we have NFC for Android, which works excellent. And Apple has not given us great low-level NFC API, so we have to fall back to Bluetooth, which is unfortunately not as convenient, but works okay. In addition to having opinions about how that hardware device is structured, there's also a certification process that is done by independent laboratories. And it is not as it's not as onerous as you might think. There's actually an open source project that made it through the certification process, and it was not notable enough for them to write about it a lot. But this helps guarantee that if you pick up a U2F device that's FIDO or certified, it's actually going to work with all of the providers that support U2F, and that this probably doesn't have a backdoor in it, which would be nice. So let's talk a little bit how it works. So it's all based on public key cryptography, which, just to review, means that you encrypt stuff, but instead of having a single secret that you use to encrypt and decrypt things, you have two secrets. You have a private key, represented by a gold key here, and a public key, represented by a green key. And what's cool about it is when you take something and you sign it or you encrypt it, that can only be verified or decrypted by the opposite color key. And it works both directions. So if I have something and I keep my yellow key secret, and I encrypt it with that yellow key, but I share the green key with somebody, they can verify that it was just me who did that, who encrypted that thing. And it works the other way also. Within the kind of U2F spec, we also have some different actors that we're going to be kind of describing the protocol around. We have our user who wants to access stuff on a service. They have a nice hardware device that they will be using, part of the user in this case. And then they're going to be using a device to connect to that third-party service, because we can't connect to APIs and web apps through with our mind. Well, not yet anyway. Maybe someday. And the specification defines a number of different ceremonies. I always like the dance analogy better, but ceremony is kind of what happens. And this is where the specification touches the user. The user has to play specific roles in parts of the protocol. There are a few different ceremonies that U2F specifies. We have a registration ceremony, which is how we share that green key with the server. We kind of authorize that device to be used in the future to authenticate us. We have the most important ceremony, the authentication ceremony, which is how having an already agreed upon key exchanged, how I use that to authenticate myself as only me. And then finally, one that is not actually specified as a ceremony in there, but is the first thing that comes to everyone's mind, which is the kind of lost key pseudo ceremony. What do you do when someone loses their key? So let's peek at each one of these in a little bit more detail. So first, our registration ceremony, how we get that key across that internet. So this is going to start with already done authentication. So we're going to assume that you have some way to authenticate with that service. Maybe that authentication just means they signed up for a new account, so I know they're the person who just signed up. Or they use some other kind of authentication mechanism, like login and password. Once you've completed that step, then you click something on a website that says, hey, I want to register a new U2F key. And it goes, great. The server is going to send over a couple of things that's used to do the rest of that dance. It's going to send over a challenge, which is essentially a randomly generated number. It's going to send over an application ID, which usually corresponds to its domain name, but in mobile apps it's a little bit different. That's going to go to your device, your web browser, or your mobile app. And at that point, the challenge will get passed along, and one thing is going to get added. The origin field, which is the domain name and protocol that is taken from your web browser. And this means that we're kind of we're standing on the shoulders of giants, in this case the giants of transport layer security. We're assuming that TLS is working and is properly identifying the domain name of the site. So that somebody man-in-the-middled it and had a different domain name there that has a 0 instead of an O, these are going to be different. So with that app ID, origin, and challenge, they're going to get passed to your physical device. And at that point, it is going to use these things to create a key handle, which is an ID for your key that is generated by the key itself. So the dongle is going to generate a key handle for this particular account and particular server. It's also going to generate a public key. It's going to encrypt some of that registration data and sign some of the rest of it, and then pass it back along on that secure connection with the key handle that is generated and a certificate that describes a bunch of information about that key, like who manufactured it, when it was manufactured, what versions of the protocol it supports, all that kind of stuff. As well as the origin that it saw in the web browser. Because if the origin gets all the way back to the server and the server's like, that doesn't match, it's also going to, that's a sign that something else has gone wrong. So at that point, it verifies the payload, and the server will save a copy of that key the public key that was given to it, as well as the key handle so that it can use it for later. Okay, so that part's a little bit of a mouthful. Let's kind of like use the authentication ceremony as an explanation for why all those steps were actually important. So like it did a bunch of stuff there. Let's kind of add one layer of complexity at a time to explain why they bothered to make this protocol have so many steps. So when we do authentication, we have already done that key exchange. So there's a public key sitting on a server and a key handle. We're going to start with another traditional form of authentication, kind of our primary auth, like a login and password. Once that has been successful, the server will remember, like, hey, this user had a security key. So it'll generate a new challenge. Every time the challenge happens, it's a big string of random stuff. It's going to send it over to your web browser. Your web browser will run a JavaScript function that will ask for a key. At that point, it'll pop up and say, hey, hit a button on the key. And the key is going to sign the payload and send it back. This is great and all, but it doesn't use some of the other features. And more importantly, this doesn't actually protect against man-in-the-middle attacks yet. So we had to add another layer to that authentication ceremony to do it. This is where that origin comes in. Not only during registration does it guarantee that the site is the same, but if the man-in-the-middle pops up later, the origin can be used to verify against the key handle that was generated by the device and is stored on the key to see if that domain has changed. If the domain doesn't match, the key knows it's a problem and it's going to not finish the authentication dance. The key handle also gets returned by the server every time you authenticate. What this does is it further further protects against phishing or man-in-the-middle attacks at different points in the chain, but it also has a privacy benefit. So if you have multiple accounts on a single provider, the key handle is what allows your security key to have a different private-public key pair for each one of those users. And this prevents that server from correlating all of your different identities. In other words, you can use a security key over and over and over again with the same service in different accounts and with different services handled by the same provider. So like Google has a bunch of different services. You might be using your key for your G Suite account, for your Google Cloud Platform stuff. And the key doesn't want to expose that key was used for multiple things, because that's a privacy issue. And then finally, there's one other thing. Since we already have this cool dance, we can add some other features to the flow that will protect us against a different kind of attack. So it's quite possible, it's actually very difficult, but possible for somebody to take, if they have physical access to your key, to clone it. So they could take your key, they could probably do some destructive stuff to it, and probably make some clones of that key and maybe slip it back to you. Maybe you won't notice that your key has been cloned. This is honestly kind of the realm of sponsored actors. So somebody's going to have a lot of resources to want to go after you, but we want to use this to protect those users too. So the protocol has a built-in clone prevention or clone detection system also. And to do this, we take advantage of the only thing that differentiates two different clones. So clones all share the same history, but their futures diverge once they've been cloned. And that's the secret here. So we put a counter on each device. And every time you authenticate, we increment that counter. So that if the device has been cloned, that counter is going to seem to go backwards or stay the same. So the server, in addition to keeping track of that key handle and that public key, will keep track of a counter. And if it ever sees that counter go down, it'll know that a clone exists. But it won't know which key is the clone. So in that case, it's probably just going to lock out the account altogether. The protocol does not specify, it just says that there's a clone. React how your server should react. In general, what most providers do is they just lock your account and fall back to secondary authentication. So that is the authentication ceremony. There's one more kind of pseudo ceremony, which is what do you do if you lose your key or your customer loses their key? And this is the first question that pops into everyone's mind when you have a physical aspect of your authentication. But the truth is, it's not really that different from any other thing. Like what happens if that one-time password app gets deleted, or if you forget your password? You do the same thing. You fall back to a secondary method of authentication, which is hopefully similarly secure, or at least almost as secure, not considerably weaker. But because it happens much less often, you can do something that takes more time, something that's less convenient for the user. This will typically be a combination of different things like an email reset and maybe, do you remember your last password, that kind of stuff. So let's take a look at this in action. Enough of the pretty pictures. Let's see some code-like stuff. So there's a wonderful website out there that you can use to test your U2F devices, which is also a great debugging tool to kind of see what's happening in the payloads while you're using it. And Yubico makes it, which is a manufacturer of a lot of U2F keys. They make some pretty slick ones that have a bunch of bells and whistles. They're pretty cool. And here's this little test page. And what you do on the test page is you kind of simulate signing up for an account. So let's simulate signing up. I'm going to make a user. I'm going to have a really strong password. And I'm going to register an account. And it's going to pop up something that's telling me to hit my key. And my key has actually started physically blinking. So I can see that this is a real U2F request because my key is blinking. I'm going to press that button. We're going to hope it actually works. Oh no, the demo effect. We're going to reload the page and try again. Boop. We're going to fall back to the pre-recorded video. Oh my gosh, demo fail, sad face. Okay, so I have a better video. I have one that's not cropped. Just a sec. I will fall back to the correct video. So what happens is you will go and you will log in with your super strong password. It will ask you to. You will hit the button that will be blinking at that time. My browser will ask me if I want to use a security key. And this is from Yubico, so it actually doesn't know how to identify non-Yubico devices, but that's OK. This is from a different provider. The rest of it still works because standards. And we can see that my login data is up there, and we can see the registration data that went down. We have the origin, we have the app ID, because I'm only seeing what's being dumped by my browser, as well as the challenge that came in, which is a big block of gibberish. Then we have the response data that is coming back from the key. There's some client data that the browser is seeing and sending back. And then there's this registration data, which is a big old blob of opaque binary stuff. And that's because the wire protocol for the device is actually, it's a binary protocol, this part of the spec. It's just a little harder to read. But in there is the signed version of all those registration details and some other stuff that's been encrypted. And with that, during registration, we also send up a certificate that describes all the details of the key. This is a version 3 of this particular key. It has an issuer identifier, so if you wanted to ban an entire manufacturer for some reason from your authentication system, you could. Okay, let's go to the second part of the dance, the authentication dance. So now that we're registered, we can use that to authenticate. We can see, again, my very strong username and password. And you can see that the authentication flow is a little bit lighter. There's a key handle that the server remembered from when I registered, and it's sending it back over so that I can find the right private key to do the signing, and a new randomly generated challenge. I send that response, which is the same information that's been signed by my private key, and we can see that there's a counter there, which is currently set to 22. And if I do the dance again, we'll see that the counter has incremented. Similar technical data, a different challenge, and the counter went up by 1. It also says that I touched it, which is part of the spec, but I think touched equals true is the only valid value right now. So yay! Authentication-y stuff works. So hopefully I've convinced you that this thing is cool and it actually protects you against a bunch of attacks and is totally worth the pain in the neck of carrying a thing around. So how do you use it yourself? If you want to use it to protect yourself, you're in luck, because if you use one of these kinds of web browsers, your web browser probably already supports it. Any Chromium-based browser has support via kind of a hidden plugin that's built into the browser. So that includes Opera and Chrome. Firefox added support a few months back, which works really well. It's pretty slick. And Safari has support that kind of works via an extension. The one noticeably missing element here is, of course, Edge. Edge looks like they're going to be skipping over the U2F spec and implementing the WebAuth end stuff pretty soon, hopefully. And that will have reverse compatibility to the U2F keys. So coming soon. And lots of different because the servers also have to support stuff. A lot of different websites already support it today. So a lot of the Google stuff supports it because we think it's kind of cool. and we understand the need for it. But there's also a wonderful website called dongleauth.info, where you can type in the names of different things and find out who has support for universal two-factor authentication. It turns out Fastmail added support. They actually added support pretty early on, but you can find a whole bunch of providers here. I actually come back to this website every once in a while to make sure that I'm using U2F everywhere I can, because it is good at protecting you and stuff. So that's how you can use it to protect yourself and your data on other providers, which I encourage you to do as your first step. Protect your own stuff. Set a good example for all of your users around you. You can additionally add it to your own services out there. So we all spend a lot of time deploying code and making sure it runs well. What if we want to use it to protect our kinds of stuff? You have a few different options. You can run it yourself. You can use third-party authentication, and I'll tell you a little bit about how Google does it. So first, if you want to run it yourself and you have access to the code of an application, this is great. You can just use one of the client libraries. This is how most people seem to implement it. These are the most popular way. There's a whole bunch of client libraries up there on GitHub. The most popular ones are written by Yubico, but there's some other libraries that are pretty well supported also. They're available for every language I've used in the last few years. So Yubico, I think the most popular one is the PHP library. Or because microservices are all the rage now, they also have Yubico has a reference microservice U2F authentication service that's like independent, which might be useful if you want to partition off this part of your infrastructure to have more strict security rules and that kind of stuff on that system. It can definitely have its own advantages. It is less popular. It has like fewer stars and fewer commits, so it's a little bit less mature. I haven't used it in production. I don't know how well it works. Because especially you want anything that's part of your authentication flow to be super reliable. But if you don't want to deal with any of that, there's always the federated auth option. So if you allow sign-in to any of your services via a Google account, a Facebook account, a GitHub account, and some others, you already have the option for your users to have U2F support, which is pretty cool because they can use U2F for these accounts, which means that if they can use this information to authenticate elsewhere, they have the option of being protected by universal two-factor auth, which is actually a really good reason. I use federated auth at a lot of places just because I want to have U2F authentication behind it. And then at Google, we took a little bit of a different approach. This is kind of baked into our overall Beyond Corp strategy, which is a whole talk in itself and is a very broad thing, but kind of the core, one of the core components of our Beyond Corp strategy of making a lot of our internal services exposed to the internet is this kind of identity-aware proxy thing, which is kind of like an SSO meets a proxy so that we can restrict access to different applications and even sections of applications like different path segments and tie those to specific user groups and then have those user groups, like if they have access to privileged information, require stronger authentication from them. And this is actually a commercial part of Google Cloud Platform. So if you have stuff running there already, like it's cloud native up there, it's an option. It's kind of a turnkey thing. I've used it before to just lock down the admin page of like a WordPress instance so that the WP admin requires you to, all the users who have access to WP admin are forced to use universal two-factor auth, which is great because those things get pwned all the time. So wrapping it all up, in conclusion, hopefully I have taught you a few things today. First off, the passwords aren't enough. That's the easy part. I think we all admit the passwords are not enough and that they're not very fun. The security keys not only work, but are good enough to warrant the fact that we're going to carry around a separate piece of hardware. And hopefully, you are inspired to go get a security key. They only cost a few dollars and use them on your own accounts. And I have a couple. If you poke me after the talk, I have a couple that I can hand out. And that there are many different options to use, especially for people who have access to lots of different resources, like can push access to important GitHub repos and stuff. This is a good option to encourage them to use universal two-factor auth so you don't have to clean up the mess that happens when they get phished. So on that note, thank you very much for sitting and listening to me talk about authentication. And if you are interested in this topic, I have a slide with a whole bunch of different kind of long reads attached to the end of the slide deck. So if you go grab the slide deck, you can learn a lot more. Take advantage of all my research. So thanks so much.